at this point, what we've seen is that there is a difference in the division, sympathetic versus parasympathetic, what's getting released from the pre and the post fibers. So the acetylcholine, cholinergic, and now adrenergic for the norepinephrine, because these are major players for the autonomic nervous system. Now, when we have an effect on a gland, remember, gland. What can I be referring to in our body?
Something that secretes a hormone.
Well, in thinking about this, because a lot of times when we hear the term gland, we tend to think oil gland, sweat gland, okay? For the most part, we're looking at our instrument, okay? So we're going to be looking at glands that get affected throughout the body. Think about your thyroid, pituitary, that sort of thing, okay? And especially our adrenal gland. So, when we look at the differences, okay, autonomic effects, auto meaning the ones that are going to happen based on the tone, okay, that background firing, based on the tone that the two divisions are keeping, okay? Remember, they're maintaining homeostasis. So, usually, we get an indirect result, but this is for our blood vessels. Blood vessels being a part of the cardiovascular, all right? Once again, we have innervation to the heart, but it does not control the action of the heart. We can affect it, but it doesn't control it. But for the vessels of the body, okay, the blood vessels, they are actually innervated. They are actually, for every vessel that we have, it has a nerve leading to it. So they're actually innervated. So therefore, if we look at the vascular system, it is made up of smooth muscle, meaning controlled by the autonomic nervous system, because it's smooth muscle. The system works to either make those blood vessels. Now, here's the thing though. When you think of blood vessels in the body, what do you think about? Do you think about like this, like what you might see running in the arm or through the neck or whatever? Is that what you think about? Okay. Is that where any type of activity occurs? No. Where does it occur at? Because yes, all right, capillaries. Ever heard of those? All right, here's the thing though. They're microscopic. We can't see them. I can't like look at my fingertip and be like, oh, look, capillary bed, capillary bed, capillary bed, capillary bed. I can't do that. However, I get a paper cut, I know it's there, okay? Chink, I've definitely cut through those capillaries, all right? That is where everything takes place. So, if the body, for example, needs to make sure that those blood vessels dilate it's happening at that microscopic level. It's happening at the level we can't see. And it's occurring at this outermost layer that we can get to for blood flow. Dilating means the blood flow increases to those tissues. So sympathetic would be doing that. Sympathetic would go to the vessels, make them dilate, and increase blood flow to my skeletal muscles. Why? Because my sympathetic is for fight or flight, and for fight or flight, my skeletal muscles need to be ready to fight or flee. Now, once I'm past my danger, all right, and the parasympathetic kicks in, the parasympathetic, those vessels, they're going to constrict, blood flow is going to decrease to those tissues, and it's going to push it back to the core of my body, so my viscera, for example, the digestive system, can start acting again. So they will cause, or basically the two divisions can actually have an effect on directing the blood flow, which is kind of cool. One of the things that I mentioned, and we kind of talked about, which of the systems have the longer effect? The sympathetic division, most definitely, because the sympathetic division has that connection to the medulla of the adrenal gland, which is going to release norepinephrine, which is a precursor to epinephrine, which is the hormone that will go into the bloodstream, go to the cells of the body, excite them, and then we have to wait for the rest of it to get broken down. And that takes a long time. So depending upon what the danger or the perceived danger might have been to ramp up that sympathetic division, it could take minutes to hours to days to a long time decreasing those sympathetic effects.
Is that like PTSD?
Yes. Because they're in, they think that they are in, you know, because they've been in the danger situations and all those chemicals got released, okay? And not only does the body get adjusted or used to that production, it's kind of a feeding cycle, and it's a difficult one to break. Now, when we begin to think about these neurotransmitters, okay, well, we have to make sure that we can modulate these effects, all right? For example, when you guys were talking about the muscular system, could we always have acetylcholine available at that neuromuscular junction? Or did there have to be some way for us to, or the body I should say, to get rid of it? You happen to remember at the area where the nerve met the muscle, at the neuromuscular junction, and acetylcholine got released? What would help get rid of it? You guys remember anything? It's a really cool term. It's fun to say.
Oh, it's black.
Acetylcholine methylate, an enzyme to help break it down. So we had kind of a little bit of a control, okay? Well, we still have to make sure that we have ways to control some of these hormones, all right? Can't just keep having constant release, all right? Under normal conditions, each one stays a little bit charged so that we maintain homeostasis. But now our body has very interesting ways, depending upon how we may need it, okay, as to getting the release of the chemicals. So, sympathetic fibers. Do you guys remember any of those chemicals right there from part 1?
Neuropeptide. Neurotransmitter.
Which one?
Yeah, I think it was like part of
Yeah. Do you guys remember talking about the digestive system?
Yes.
These were chemicals that were strictly for the gut-brain peptide. All right? And the goal was for these chemicals, because we're looking at them being released synthetic, this means it was to help for controlling appetite. Okay? Appetite, satiation, and so forth. Some of the parasympathetic fibers, they release stuff like nitric oxide. Don't confuse it with nitric. That's the dentist's office. Okay, nitric. And this is really cool because what it will do when it releases the nitric, it'll cause vasodilation. Can you think of anything that comes to mind for that? Other than what's listed. People who have heart problems, sometimes what do they put under their tongue?
What's that?
Nitroglycerin. That'll blow up a building. And you take that on a little pill and put it under your tongue. Go figure. What does it do? Dilates the blood vessel, stops the pain, increases blood flow, and hopefully you can make the heart be okay. That was the basis for these medications we see nowadays, such as Viagra. Took me a second. Cialis. But what does it do to the man who takes it? Doesn't only open up those blood vessels to the heart, or to the penis, I should say, it opens it up to the entire body. And they can get the flushing and all this other stuff throughout the entire body, because it's dilating the blood vessels, which make the blood go to all tissues of the body. So, do you guys remember this picture right here? Let's take a peek at what this is telling us. This is showing us what happens when we get the release of these neurotransmitters with our pre and post fibers to their target cells. Now think back to a few slides ago about the fibers releasing their certain chemicals, all right? The pre versus the post, both the systems, so on and so forth. Right here, the parasympathetic. With the parasympathetic, my preganglion. Here, sympathetic, sympathetic. What do you remember about the release for each one of these? What is their chemical that each one of those releases? My acetylcholine. It's at the other one, on the post. where differences can occur.